Okay, so today's lesson is going to be all about inverse functions. Um, and so to build up to a concept of what an inverse function is, we're going to do some warm-ups involving identities and inverses so that you can get a sense of what an inverse means in the context of a function, specifically in the context of compositions of functions. Okay, so this first warm-up says to find the missing value that makes all of the equations below true. So in other words, what value can be added to each of these values to return the original value? So we have 5 plus blank equals 5, blank plus 5 equals 5, negative 8 plus blank equals negative 8, blank plus negative 8 equals negative 8, x plus blank equals x, and blank plus x equals x. So take a minute, pause this video, and see if you can figure out for each of these equations what value goes in the blank to make them true. Okay, hopefully that's enough time. And what we should see is that 5 plus 0 equals 5, 0 plus 5 equals 5, negative 8 plus 0 equals negative 8, 0 plus negative 8 equals negative 8, x plus 0 equals x, and 0 plus x equals x. And so what that means is that 0 is the additive identity, because any number plus 0 equals that number, and 0 plus any number equals that number. When you're adding with 0, you just get that whatever number you're working with back. Okay, now let's see if we can find the multiplicative identity. So find the missing value that makes all the equations below true. So again, I'm going to say pause the video and see if you can figure this out for yourself. What number is going to go in each one of those blanks? And what you should see is that 5 times 1 equals 5, 1 times 5 equals 5, negative 8 times 1 equals negative 8, 1 times negative 8 equals negative 8, x times 1 equals x, and 1 times x equals x. And so that means that 1 is the multiplicative identity because any number times 1 equals that number, and 1 times any number equals that number. So when you're multiplying with 1, whatever number you multiply 1 by, you just get that number back. Okay, so now let's see if we can find the subtractive identity. So take a minute and pause this video and see if you can find what number goes in each one of these blanks. Okay, hopefully that's enough time. So what you should have seen is that negative 5 minus 0 equals 5. However, for the second blank, 0 doesn't work because 0 minus 5 doesn't equal 5. It equals negative 5. Your second blank will actually be 10. 10 minus 5 equals 5. And negative 8 minus 0 equals negative 8. But 0 minus negative 8 doesn't equal negative 8. That would be positive 8. So this is actually negative 16. X minus 0 equals x, but 0 minus x doesn't equal x. That would equal negative x. So this was actually 2x. Okay? What does that tell us? Means there is no identity for subtraction because 5 minus 0 equals 5, but 0 minus 5 does not equal 5. There's also no identity for division. So we could do a similar warm-up for division But I think what we'll find is that there is no number that can be used to there is no number that can be, you can divide every number by and always get the same number back. Right? It works in one direction but not in the other. Okay, so now let's talk about this in the context of composition of functions. Remember that the function operation that we learned yesterday was called compositions of functions. We use this operation to substitute a function into another function to get an entirely new function. Okay, so this is one of the functions that we were working with yesterday. So to find the identity for this operation, we are going to be looking for a function, g of x, that satisfies the following equations. So when we compose f with g of x, it equals x squared plus 5. And when we compose g with f of x, we also get that function, x squared plus 5. Well, it turns out that function is just g of x equals x. Right? So if I were to substitute x in for f of x, I would just get x squared plus 5. And if I were to substitute x squared plus 5 into x, that would also give me x squared plus 5. All right, so that's an important takeaway, is that x is the identity when we're talking about compositions of functions. So now, hopefully, now that you guys have a sense of identity, we can start to talk about inverses. So, warm-up number 4, let's find the additive inverse of these numbers. So in other words, and what that means is, what number can we add to 5 to get the additive identity, which is 0? Right? Same thing with -8, same thing with x. So take a minute and see if you can figure out what values go in each of these blanks. So go ahead and pause the video and see if you can figure it out. All right, hopefully that's enough time. 5 plus -5 equals 0, and -5 plus 5 equals 0. -8 plus 8 equals 0, and 8 plus -8 equals 0. Okay, so what does that mean? That means that 5 and -5 are additive inverses of one another, and -8 and +8 are additive inverses of one another. How about the generic x? Well, that would just be -x. So x and -x are inverses as well. So for any given number x, its additive inverse will be -x, because x plus -x equals 0, and -x plus x equals 0, and 0 is the additive identity. So whenever we're looking for an inverse of a given value of a certain operation, we're looking for what value can we use in that operation. So in this case, the operation is addition, and the value was x. What value can we add to x to get the identity in that operation? And in this case, the additive identity was 0. We'll do the same thing with multiplication here. So something times 5 equals 1. 5 times something equals 1. Something times 5 equals 1. -8 times something equals 1. Something times -8 equals 1. X times something equals 1. And something times x equals 1. So pause the video, see if you can figure out what goes in each one of those blanks. This one's a little bit trickier than warm-up number 4, but I think you guys can do it. Well, in this case, we're looking actually for fractions. So 5 times 1/5 is 1. 1/5 times 5 equals 1. -8 times -1/8 equals 1. -1/8 times -8 equals 1. X times 1, oh, that's a mistake. That should be 1 over x. Whoops. Not -1 over x. Apologies. X times 1 over x equals 1. And 1 over x times x equals 1. Okay, so for any given number x, its multiplicative inverse will be 1 over x, because x times 1 over x equals 1, 1 over x times x equals 1, and 1 is the multiplicative identity. All right, inverses in compositions of functions. Two functions can be described as inverses of one another if f of g of x, which is the same thing as g of x being plugged into the function f of x equals x, and g of f of x, which is the same thing as f being plugged into the function g of x equals x. So if you plug the functions into each other, and it's got to work both ways, and you get x as an output, those functions are going to be inverses. Now, as we'll see, there's actually a little bit more to the story than this, and we'll talk about kind of what piece we're missing here tomorrow. But this is what it means for two functions to be inverses in algebra. If f of g of x equals x and g of f of x equals x, then those functions are inverses. So this is why it's really important that you've kind of worked all the way through yesterday's homework before you try today's homework, because this lesson's probably not going to make a lot of sense if you haven't learned how to do compositions of functions yet. So if you haven't, go back and try that lesson, try to do that assignment before you move on to this lesson. Okay, are these functions inverses? So our functions are f of x equals x squared plus 5 and g of x equals x minus 4. So we looked at these functions yesterday. Or we looked at similar functions yesterday. Okay, so this would be f of g of x. So I'm taking g, which is x minus 4, and I'm plugging it in for x in f of x. So I'll multiply out x minus 4. This will be x squared minus 4x plus 16. And so I'm getting x squared minus 8x plus 16. So that those first three terms all come from the inside of the box. And then the plus 5 at the end here gets tacked on the end. And so then this will become x squared minus 8x plus 21. So I can already tell you that these functions aren't inverses because this didn't equal x. If it had equaled x, then maybe they would be inverses. I have to do it both ways, though, either way. I'll do it the other way just for practice. So now I'm going to plug in f of x into g of x. So wherever I see an x in g of x, I'm plugging in the function x squared plus 5. You don't really need the parentheses for this one. And 5 minus 4 is 1, so this will become x squared plus 1. And again, this doesn't equal x, so we can say that f of x and g of x are not inverses. Okay, now let's try and do an example where they are going to be inverses. So we'll do 1/3 x minus 6 and 3 times x plus 6. So I'm going to take f of g of x. So I'm taking 1/3 x minus 6, and I'm going to plug in 3 times x plus 6 in for x. So that'll look like this. Right? I've got my 1/3, and then in this set of parentheses, the outside set, I plugged in the original function, or the function g of x. Okay, so the first thing I'm actually going to do is multiply 1/3 and 3. And those will cancel each other out because they're multiplicative inverses. Okay, so now this second set of parentheses is unnecessary because there's no multiplication outside anymore. So I can just get rid of that. So this will become x plus 6 minus 6. And that equals, hold on a second here, that's a mistake. Okay, and that equals x. Let's try it the other way around, g of f of x. So first of all, I should say it's looking like these might be inverses because f of g of x equaled x. Let's see if g of f of x equals x. And so we'll do 3 times 1/3 x minus 6. So we're putting in 1/3 x minus 6 for x in this function. Negative 6 plus 6, that equals 0, so those cancel out. So that leaves us with 3 times 1/3 x. 3 times 1/3 will cancel each other out, so that leaves us with x. So f and g of x are inverse functions, because f of g of x equal to x and g of f of x equal to x. Right, so when we composed the functions both ways, we got x as a result. Okay, that's it for today's lesson. Let me briefly talk about your homework. Your homework assignment is going to be to look over the functions from yesterday's homework, so the operational function, composite functions, and you're looking for two things. So you want to figure out which pair of f of f of x and g of x were inverses of one another. So if you look over all the questions from yesterday, in one question, f of x and g of x were inverses of one another. And then you're going to determine which function f of x has a right inverse but not a left inverse. So in other words, and I'm going to zoom in on this so you can really see it. When you do f of g of x, you get x, but g of f of x does not equal x. So see if you can make sense of that. F of g of x does equal x. G of f of x does not equal x. See if you can figure that out, and then that is your homework assignment for today. Once you think you understand which functions are inverse and which function f of x has a right inverse but not a left inverse, then you can post about it on this discussion.